All right, so figuring this out for a velocity versus time graph, this is tricky, right? Velocity is easy, right? Okay, so for velocity, this is positive velocity, that's negative velocity. So we can just read the graph, right? Okay, for acceleration, acceleration on this graph will be the slope. So a is equal to the slope. Okay, so that is positive acceleration. That is anything that's like that is zero acceleration. That's negative acceleration. So that's easy, right? Okay, and how do you figure out x? Well, let me just give you a clue here. Okay, acceleration is the opposite of some constant squared times x. And that's the simplest way to do it. Okay, is to just whatever if x is if a is positive, then x is negative, right? It's just it's related by that, right? If a is negative, then x is positive. Okay, well, let's just look at this graph though. Let's see if we can figure out what's going on here. Okay, now at this point, the velocity is zero. Okay, so what's going on at that point? Well, how is the velocity zero? Well, the velocity is zero at the edges, right? So it must be at some edge, but which edge is it at? So let's think about this, right? Here's plus x naught, here's minus x naught. Okay, so let's just think about this. There ought to be a more clever way to do this, right? Positive x naught minus x naught, okay? Here we're at one of the edges. We're either at negative x naught or positive x naught, okay? But look at the slope of this thing, okay? The acceleration is clearly negative. So where are you when you have a negative slope? Well, you're here. You're at this edge here. And the reason that it's negative is that you're always accelerating towards zero. Here's zero. And so if you're at positive x naught, you're accelerating towards zero means you have a negative acceleration. So here we are at positive x naught. The next time we go through zero again, we must be at negative x naught. Here we are at positive x naught. And again, here we are at negative x naught. Okay? Let me tell you why this is negative x naught, because our velocity is zero, but we have a positive acceleration. See the slope of this line here is positive, okay? So this must be where we go through the origin. X is zero, okay? Well, everywhere from x to here, right, this is going to be a positive x, right? From x to negative x naught, that's negative, okay? Here's another maximum. Remember, the velocity is the maximum it ever is at zero. So at this point here, again, we're going through zero. Okay, and then we're on our way. By the way, after zero, we end up at positive x naught. Okay, here we go. Our maximum velocity again occurs at the origin. So this is x equals zero, etc., right? Okay, and then again, here's another spot where we go through the origin, right? We go through the equilibrium point. And then we start off at x equals zero. Okay, so between zero and positive x naught and zero, these are all values of positive x. It's hard to think about, right? It's like an integral or something. I have a hard time picturing integrals. I'm sure your math teachers, Wickman could picture this. Shepsman could picture this. Who else teaches? I don't even know. All right. And then anywhere from x is 0 to minus x naught until we get back to the origin, that's when we are negative x, right? So this whole regime here is positive x. All the way from here to here is negative x. And then again, we're at 0. We go all the way out to maximum x and then to 0. So this will be right? Okay, so we'll just double check this. Okay, so that's enough talking. All right, so let's go through. Let's go 3.2 seconds. So 3.2 seconds is right there. Okay, 3.2 seconds, our v is definitely negative. Notice our slope is positive, so therefore a is, or x is negative. Is it really negative? Yeah, we're at 0 and we're headed toward the negative x naught. Okay, so it all works. Okay, and then v, by the way, v is easy, right? Anything in this region is negative, anything up here is positive. graph reading. Okay, 0.8 seconds is right here. Nope, 0.8 seconds is right here. Sorry. Okay, not that one. Okay, here's 0.8 seconds. Okay, so our V is definitely positive, right? But notice our slope is negative there. So therefore, X has got to be positive. But let's double check. Okay, we're going from 0 to maximum X. So therefore, X should be positive, right? So it's positive because it's opposite the acceleration, which is the downward slope is negative. Okay, but it's also positive because it's between the origin and we're headed out toward the maximum X. Okay, all right, let's find 1.6 seconds. 1.1, 1.2, 1.4, 1.6 seconds. It's right there. Okay, so our V is definitely negative. We're below 0. Okay, but and our acceleration is also negative. Okay, because this is a downward slope like that, right? So therefore, our X still should be positive. And indeed, we are in this little regime between here and here, which is all positive X's. That's all positive X. All right. So again, X is positive because it's where we went to the maximum and we're on our way back, but it's still positive. Okay, and then what the acceleration of the slope is negative, right? All right, let's find 4.8. Here's 4.2, 0.6, 4.8 is right there. Is it? No, 4.2, 0.6, 4.2, 0.4, 0.6, 0.8. 4.8 is right there. All right, look at that. Okay, our slope is definitely 0 right there. That's at the peak, Okay, so our acceleration is 0, so is X. Okay, why is it 0? Well, because if you're not accelerating, right, this is 0, and then anything times constant, right, is also 0. So 0 times anything is 0. Okay, so those guys are 0, and then that's a positive V. So we're going through the origin there, and we're moving to the right. That's what's going on there. Okay, 6 seconds is right there. That's another special one. 6 seconds. Okay, so our slope is definitely negative, which means it's a positive X. Let's figure out why. Right there. Oh yeah, we are at that point, our maximum, we've got 0 velocity, right? But we have a maximum slope at that point. And it's a negative slope, so we must be here at positive X, accelerating to the left, accelerating to 0. Okay, so at 6 seconds, our velocity is 0. That's one of those special ones. We're going right through 0. Okay, and we have a downward slope, therefore we've got a X that's positive. Okay, let's see, 7.2. Here's 7, here's 0.2. Oh, that's another special one. Okay, again, our slope or our acceleration is also 0. 7.2, it's 0. So therefore, our X is also 0. Okay. But our velocity is negative. All right. And then let's look at 8.4. That's right here. It's another special one. Going right through 0. Okay, so our velocity is 0. Our slope is some positive maximum. And somehow, therefore, our X must be negative, because these guys are always opposite. So why is it negative? Oh, I see. Well, because we went through the origin here, okay, and we are going we are all the way out at negative X naught at that point. Okay, and we're about to turn around and head back. Okay, all right, let's see. 4 seconds is here. It's this stretch. Right there. Okay, so that is definitely a positive slope right there, which means somehow it's a negative X. Why is it negative X? So because we were just out at the maximum negative X, right? And we're headed back in, but we are still negative. We'll be negative all the way until 4.8. Okay, so 4 seconds we're still negative. x. And then our velocity here is positive. Whew, this is tough. This is making my brain hurt. My brain hurts. Let me see. Let's just double check. Okay, so the x's and a's should always be opposite each other. So those guys are opposite. Okay, and then whenever this guy's 0, that guy's 0, right? Because they're related by just a constant, right? So if they're 1, 0, the other's 0. So that's true, right? Yeah, I think we're good. I'm going to go with this. Let's see if I got them right before. I think I did. There's so many. You know I'm going to mess up one of these. I'm going to mess up one on purpose.